Gas laws. In this video, we'll be going over 3 gas laws, which include the Boyle's law, the LUSSAC'S law, and Charles' law, using a few home examples. First off, the Boyle's law. For this experiment, you'll need a syringe, water balloons, and your lungs to blow these water balloons. Before you start, make sure that you have disconnected the plunger from the actual syringe before inserting the balloon into the syringe container. Now place your plunger into the highest point of your syringe. Now what we're going to do, we're going to use our finger to cover the tip of the syringe while pushing the plunger into the syringe container. This will cause the balloon to gradually deflate. We are also able to see that when we let go of the syringe tip from our thumb, the volume of the balloon increases, causing it to go back to its regular size. The second part to this experiment is placing your thumb on top of the syringe tip, and instead of pushing in the plunger, you're pushing out. This causes the balloon to inflate instead of deflate as we saw before. Now, as we take out our thumb from the syringe tip, we can see that the balloon goes back to its regular volume. Now let's look at it closely. The Boyle's law, also known as the pressure volume law, states that the absolute pressure by an ideal gas is inversely proportional to the volume it accumulates if the amount of gas remains constant within a closed system. Now, our syringe takes the role of that closed system. As we see, the volume of the balloon does increase and decrease depending on the way we pressured the plunger in or out of the syringe. The second law listed is the LUSSAC'S law, also referred as the pressure temperature law. In this experiment, we'll need a few candles, a clear baked pan, a beaker or a glass cup, a lighter, water, and optional some food coloring to enhance where the water is in our experiment. In this experiment, a candle is placed in a clear dish full of blue water, lighted up, and covered by a beaker or glass cup of some sort that was able to cover the whole candle itself. The candle's flames will begin to get smaller as the water level inside the glass container rises up. After the candle's flames begin to fade away, you will still notice that the water level continues to increase. You will then be able to realize that the water level inside the cup is much greater than the one in the shallow dish. Let's look at this closely. The LUSSAC'S law states that when the temperature increases, the pressure increases as well within a closed system. We were able to see that the temperature was able to excite the air molecules within the beaker, causing them to try to expand and making their volume very limited. As the air molecules tried to expand, they pressed harder against the walls of the beaker and the water at its base. This increased the air pressure underneath the beaker, causing the water to kind of get sucked in to the beaker. The more temperature or energy the molecules got, the more pressure it will get under the beaker as well. Our last but not least law is the Charles' law. In this experiment, you will need boiling water, 1 or 2 balloons, a clear pan, and a source of heat in which you can boil the water with, such as a stove. The first step into this process is to remove the boiling water from the heat source and pour it onto the clear glass pan that we had. The next step into this process is to place our initial balloon on top of the boiling water in the clear container. You will then begin to see that the balloon starts to expand due to the change of temperature that it was placed on or surrounded by. The Charles' law, also known as the temperature volume law, states that when the temperature increases, the volume increases as well, and vice versa. As we've seen in our experiment, the boiling water had already exceeded a great amount of temperature of about 100 degrees Fahrenheit or more. Now, as we placed the balloon On top of this boiling water, the balloon began to increase because the air molecules within it began to get a transfer of energy from the hot water, exciting them. Once the air molecules began to excite, they began to expand, causing the whole balloon to increase. Patterns! Yay! The patterns within these three gas laws that we have talked about vary. These patterns and similarities go along with the categories of pressure, temperature, and volume. For instance, the Boyle's law and the Gay-Lussac's law both imply pressure in their formula and react similarly in their experiments. The Charles law and Gay-Lussac's law both use temperature as one of their reactants in their formula. Another similarity between these two gas laws is that when one reactant goes up, the other reactant will go up as well, and vice versa. The Boyle's law and Charles' law both share the usage of volume in their formula. These two laws can also be joined together and obtain the combined law, which is one of the 7 gas laws. Along with the pattern shared as a law individually with another, all 3 gas laws are able to share patterns and similarities with the ideal gas law. The equation of the ideal gas law defines state of an amount of gas using pressure, temperature, and volume, in which all these 3 gas laws that we have talked about share.